Alright, today we're talking about Chapter 4, Section 4, the division of polynomials. I hate this section. Hate's a strong word, so I'm going to use it because I hate this section. Division is, look, it's no shock. You don't like division, I don't like division, nobody likes division, but it has to be done, right? And we're going to go over it today. So the division of polynomials, starting here. Crap, what did I start to... Alrighty. Division by a monomial. Division of polynomials is presented in this section as two separate cases. The first case illustrates division by a monomial divisor. The second case illustrates division by a polynomial with two or more terms. To divide a polynomial by a monomial, divide each individual term in the polynomial by the divisor and simplify the result. So what we do here, if a, b, and c are polynomials such that c is not equal to 0, then if we have a plus b over some c, then we can split it up into a over c plus b over c. All right, and same thing can be done with the subtraction sign, right? So this is the addition sign here. We can put addition sign between two fractions. If there's a subtraction sign here, we can put the subtraction sign between two fractions. So let's go ahead and put that. Let's put all this on the first page here. Current page. Okay, so example 1. Divide the polynomial. So we're probably just going to put a on this page and b on the next page. So a, we can split this up into 3x to the 4th over 3x minus 6x cubed over 3x, and then plus 9x over 3x. And unfortunately, we're going to have to kind of go up here, make it a little cleaner. Okay, so 3x to the 4th over 3x, we know that, okay, so 3 over 3, that's just 1, and then x to the 4th over x is going to be x cubed. So that's just going to be x cubed rather. 6x cubed, 6 over 3 is 2, so again, we're going to put our minus sign there, so it's going to be minus 2, and then x cubed over x is going to be x squared. And then the last one is 9 over 3 is 3, and x over x, they cancel each other out, so it's going to be plus 3. Let's go to B. B is going to get its own page, and B looks ridiculous, but it's not too bad. Alrighty, so if we were to rewrite this similar to A, right? Because we have this division sign here, this division symbol there, right? We have the division symbol there. If we were to write this similar to what A looks like, well then it would be 10c cubed d minus 15c squared d squared and plus 2cd cubed. And that's all over negative 5c squared d squared. Okay, so we're writing it the same way that we wrote A, and then we can also proceed the same way we did A. So we could say 10c cubed d divided by negative 5c squared d squared. So we're going to write 10c cubed d all over negative 5c squared d squared. Next we're going to do minus 15c squared d squared all over, and my screen's bouncy, hang on a second. Minus 5c squared d squared, and then plus 2c d, that's cubed, right, all over negative 5c squared d squared. Okay, so same procedure as in A. What we're going to do is we're going to say, okay, so 10 over 5, that's going to be negative 2. And then C in the numerator and D in the denominator. Why is that? Because, so we've got negative 2, And then the c cubed and c, remember that c pretty much gets canceled out, and two of these get canceled out. And similarly, this d gets canceled out, and one of the d's get canceled out. Okay, so this becomes negative 2 c in the numerator and d in the denominator. And then we minus, okay, so this, excuse me, this can get a little tricky, but keep in mind it's a minus, so we're going to put the minus on the 15 up top. So that's so essentially saying negative 15 divided by negative 5. So we're going to say positive 3, right? And negative divided by negative. And of course these, they just cancel out, so that's even better. So minus 3, I didn't mean minus 3, I'm sorry, plus 3. And then the last one, we have a plus sign, so it's going to be plus, but we have, excuse me, we have a 2 over a negative 5, okay? Well, plus a 2 over a negative 5 is the same thing as saying minus 2/5, right? 2/5. And then the c, we put the c in the denominator, and we put the d in the numerator, because again, they cancel out. This c cancels out, and there's one left. This d cancels out, and there's one left. Okay. So that's how we divide polynomials by a monomial. Now, things get way worse really fast. Long division. If the divisor has two or more terms, a long division process similar to the division of whole numbers is used. So I'm assuming you've probably done long division polynomials in high school, okay? But I'm also assuming you might have forgot. Same reason why, or same way that you have probably done long division before with whole numbers, right? You might have done like 21 divided by 9, right? You might have done long division with whole numbers, but you might have forgot. Well, you're in luck. We get to unforget real fast. And let me put stuff on this side. We're gonna try that out for size. I say that because I'm left-handed, and whenever I start writing, my hand covers up the problem. So I have to kind of slow my voice and also lift my hand up. But we're gonna try something different this time. So we're gonna set this up. We're gonna say x minus 2. Let's give a little bit of space at the top there. X minus 2 divided by 3x squared minus 14x minus 10. Okay, so here's how long division goes. What we're going to do is we're just looking at this first term. Okay, we're going to see that later on, how we just look at the first term and a lot of the problems. We're just going to look at the first term in this process. And it's basically you divide and then you do it again. Divide and do it again. So what do I mean by that? So what we're going to do is we're going to start off and say 3x squared divided by x. Okay, so we're going to put that over here to the right. 3x squared divided by x. What is 3x squared divided by x? Well, that is 3x. Okay, so it's 3x. So what I'm going to do is I'm going to put it over my x term. Okay, it's very important you keep things lined up, and we'll see more examples of why it's important to keep things lined up in later examples. But we're going to put 3x right above it. Okay, and then we're going to take this 3x and multiply it by this x, and then we're going to multiply it by this negative 2, and we're going to put it underneath here. Okay, so let's go begin that process. Well, what is 3x times x? Well, 3x times x is 3x squared. What is 3x times negative 2? That's going to be negative 6x. All right. Now, once you're done with that, it's very important you do this every single time. All right. Make it a I won't say really make it a point, but I mean, yeah, definitely make it a point that whenever you get done multiplying through here, immediately go through and change the sign of those numbers that you just put down. Okay, so what I did just then was that's a positive 3x squared. I made it a negative 3x squared. That's a negative 6x. I made it a positive 6x. Okay, and then we can do the arithmetic here. Well, what's 3x squared minus 3x? squared? Well, if you do it correctly, it should be 0. I did it correctly, so it's 0. What is negative 14x plus 6? Well, negative 14x plus 6 is going to be a negative 8x, and then we bring that 10 down. Okay, that is the first iteration. Now we have to do it again. So we're going to do it again. We're going to look at the negative 8x and then the negative x, or I'm sorry, negative 8x and then 8x. I said it again. We're going to look at the negative 8x and the x again. So negative 8x divided by x is going to be equal to a negative 8. Okay, so negative 8 is a constant, so I'm going to put it up here above the constant. And then I'm going to do the same thing. I'm going to multiply it through. Okay, what is negative 8x? I'm sorry, what is negative 8 times x? What's going to be negative 8x? Negative 8 times a negative 2 is going to be positive 16. Okay, so as soon as I put it down, I'm going to change the sign. So that's negative 8x turned to a positive 8x. This positive 16 is going to turn to a negative 16. Okay, if you do it right, the first terms cancel, and they do. Okay, and then negative 10x and negative 20. I'm sorry, negative 10x and negative 16 is a negative 26. All right, and then we can stop there, but here's what would happen. We have to stop there, okay? So because we can't say negative 26, I mean we can, but we don't have a solution. Negative 26 divided by x is simply negative 26 divided by x, so we cannot proceed any further, okay? So here's what we're going to do. We're going to, looking at my my long division here, we're going to define some things here, okay? This is my quotient. Okay, I'm just going to put a Q there for right now. That's my quotient. This is my remainder. Okay, this is my divisor. So we're going to put let's see, divisor. We'll put D. I don't want to put I. We'll put DS for divisor. No, let's do DVS. Okay, divisor. And this is my dividend. And the reason why I was struggling trying to figure things out is because this is DVD, right? Dividend. Right, now obviously I didn't write them all out, but we defined what each one of those are. All right, we have the quotient, we have the divisor, we have the dividend, and we have the remainder. Now, there's a certain way you put your solution into ALEKS or onto a piece of paper, okay? That is quotient plus remainder over divisor. So the solution to this particular problem is going to be my quotient plus my remainder over my divisor. Okay, so what does that look like? Let's go ahead and put this over here. So quotient, I forgot what it was, 3x minus 8. So quotient, 3x minus 8, plus my remainder, I believe was negative 26. I'll check it out when I get there. Over my divisor, so yeah, so my remainder is true. My divisor is x minus 2. X minus 2. Quotient plus remainder over divisor. And that's it. That's the solution. Okay, and let's actually, well, yeah, let's actually make it a little bit prettier. How about that? X minus 2, I believe was it was. Okay, so quotient plus remainder over divisor. Let's actually go ahead and, this is the quotient, this is the remainder, and this is the, shoot, I forgot. Did I put R? Divisor, no, S. Good job. Way to go, Sherman. Huh. You know what? R's pretty good. Let's change this to R. So, divisor. Okay. So quotient plus remainder over divisor. That's how we do long division. All right, so we're gonna, let's see, do we go in synthetic? Okay, so here's what we're gonna do. I'm going to just kind of talk about example 3 because it's the same procedure. All right. Wait, let me make sure. Yeah, okay, good. It's the same procedure. It's just in this particular example, we end up with a remainder of 0. Okay, so when we have the remainder over 0, we still put it in quotient plus remainder over divisor. The quotient is this, right? X squared. Sorry, I don't know if y'all can see my mouse when I record. The remainder is 0, and the quotient, that's the quotient, negative x squared minus 7x minus 14. If you recall, it's quotient plus the remainder, which is 0, over the divisor. Well, 0 divided by anything is just going to be 0. So my solution here is simply negative x squared minus 7x minus 14. Okay, this particular problem is pretty much the same as example 2, with the exception of having to fill in some gaps. But we're going to do that in example 3 anyways. It's just the only difference here is that we have a remainder of 0, and that's how you put your solution in. Okay. Example 3. Let's see. Okay. Next, we're going to use long division, but we're going to change things up, and then we're going to make it the problem a little bit harder. A little bit harder. All right. So, how do we make it a little bit harder? Well, we end up having degree higher than 1 as your divisor. So, what happens here? So, it says divide 15x cubed minus 4x plus 9x to the fourth minus 5 divided by 3x squared minus 4. Okay, so here's what you have to do. You have to, number 1, put these in descending order. Okay, and number 2, you need to fill in gaps. So what do I mean by that? So let's putting this in descending order. We're going to end up having a 3. I mean, the divisor is pretty easy, 3x squared. Okay, but when I said fill in any gaps, all right, there's not an x, right? You go straight to a negative 4. I need to have an x. I need to account for the x, and we'll see why here in a moment. All right, so we're going to say plus 0x, and then we can say minus 4. Okay, and I can tell this is going to get kind of, well, I might have to get rid of the actual example up there. But anyways, now we put this in descending order, okay? So it looks like it's a 4th degree polynomial, right? But the 9x to the 4th is not in the front. It has to be in the front. So 9x to the 4th, and then plus 15x cubed. All right, there is no x squared though. So what do I have to do? I need to put an x squared there. So plus 0x squared. And again, you'll see why here in a moment. And then minus 4x, and then minus 5. Okay, so, all right. And since I put all that in there already, I'm going to go ahead and get rid of this problem because I need that space up top. All right, so long division of polynomials. Here we go. So we have a 9x to the 4th divided by 3x squared. Okay, well, what is 9x to the 4th divided by 3x squared? Well, that's going to be 3x squared. Okay, so I'm going to put 3x squared over the 3x squared part. Okay, so I'm going to put it right up here. 3x squared, right? I'm putting it over the x squared. Keeping your ducks in a row will help you tremendously in doing the computation. So please make sure you do that. Okay. You don't necessarily have to, but it definitely helps, especially when you do this part right here. Let's erase that. 3x squared times 3x squared. Okay. Well, that's going to be 9x to the 4th. So 9x to the 4th, and then 3x squared times a 0x. Again, if that 0x wasn't there, I would probably, skip over, right? But it's pretty easy. It's going to be 0x cubed, right? So that's nothing extraordinary. So plus 0x cubed, and then 3x squared times negative 4. So it's going to be a negative 12x squared. So minus 12x squared. All right, and then so I put my equal sign here. I'm going to change the sign. So this turns to a negative. This also turns to a negative. And this turns to a positive. Doing the arithmetic there, we see that this does indeed cancel. and then 15x cubed minus 0x, so that's just going to be 15x cubed, and then plus 12x squared minus 4x minus 5. Okay, that's the first step. Next up, we're going to do 15x cubed divided by 3x squared. So 15x cubed divided by 3x squared, we know that's 5x. Okay, so 5x, I'm going to put it directly over the x value there. So plus 5x, and I'm going to multiply through again. So 5x times, so this times 3x squared, is going to be 15x cubed. So 15x cubed. 5x times 0x, that's going to be 0x, so plus 0x squared. And then 5x times 4, well, that's going to be plus, or I'm sorry, minus 20x. And then we put that equal sign, and then we immediately change the sign of everything. Okay. Again, that cancels because I did it correctly. And then I have a 12x squared, and then I have a plus 16x, and then a minus 5. That's unfortunate. We're going to have a, all right, so let me move some toolbars here. I don't think you can see these toolbars, but they're there. Okay, so let's continue on, moving forward. We're going to do 12x squared divided by 3x squared. Well, 12x squared divided by 3x squared is going to be 4. So it's going to be just plus 4 up here. And then we multiply through. 4 times 3x squared, that's going to be 12x squared. 4 times 0, that's going to be 0x squared. I'm sorry, 0x. And then 4 times negative 4 is going to be negative 16. That cancels. We did a good job. Well, not yet. Got ahead of myself. I have to change the sign. But I know it cancels, right? Actually, the 0 didn't really matter. Now it cancels. I did a good job. So I've got 16x plus 11. Okay, so this got ugly pretty fast. So what happens here? Well, again, we have to put our solution in quotient plus remainder over divisor. Okay, well, it honestly, I can't pretty this up. It's simply just going to be quotient plus remainder over divisor. So my quotient is 3x squared plus 5x, and I'm going to go and put it on the next page as I have done before. So quotient was 3x. I don't forgot. 3x squared plus 5x plus 4 plus 4. Quotient plus the remainder, which was 16x plus 11, over my divisor, which is 3x squared minus 4. Okay, so that's my solution. Quotient plus remainder over divisor. And that was rough. All right. Next up, we're going to talk about synthetic division. Now, let's see, how much more synthetic division we got? Not much. So here's what I'm going to do. I'm going to use synthetic division on previous examples because, well, that's the way it goes. Alrighty, so in this section, we introduce the process of long division to divide two polynomials. Next, we will learn about another technique called synthetic division to divide two polynomials. Synthetic division can be used when dividing a polynomial by a first-degree divisor of the form x minus r. So what this is saying is the divisor must be a first-degree polynomial. So real quickly, this example, the divisor here is a second-degree polynomial, so I could not have used synthetic division on this problem. This problem, the divisor is a first-degree polynomial, so I can use it on that problem. Okay, and we will go back and do this problem here in a moment using synthetic division. Anyways, let's see. Okay, so must be a first degree divisor of the form x minus r, where r is a constant. Synthetic division is considered a shortcut because it uses the coefficients of the divisor and dividends without writing the variables. Okay, it is indeed a shortcut, but you can only use it if your divisor is a first degree polynomial. That is the only way we can use it. So, avoiding mistakes, let's see. All right. It's probably best if I just to give you an example and kind of give you, I mean, this is right. This is good. Again, I have nothing wrong with it. But instead, let's do. Uh, okay, I'll do example 6 later, but I'm gonna jump straight to what problem did I say we did? I think I skipped to. Okay, so we're gonna do this problem, example 2. Notice how long it is. It's very long. Okay. Instead, we're gonna do synthetic division on this particular problem. Okay, so let's go ahead and snip this real quick. So here's what we do with synthetic division. We're going to look at the divisor. Well, kind of the divisor, okay? In this particular case, the divisor is x minus 2. So in order to start this problem, what I'm going to do is I'm going to change the sign there of that x minus 2. I'm going to change it to a positive 2. Okay, so basically what I'm doing is I'm taking the opposite sign of that particular constant. Now this will always be the case with synthetic division because, like I said, you can only use synthetic division on first degree polynomials. It is x minus 2. On the previous example, again, this is an x squared, 3x squared. I cannot use synthetic division on that particular problem, but I can here because it is an x, just first degree. So first thing I'm going to do is I'm going to take the opposite of it and I'm going to put it in a little box all by its lonesome. Okay. Next what I'm going to do is I'm going to take just the coefficients of my dividend, right? My dividend being this. Okay, so I'm just going to look at my coefficients. So 3, I'm not changing the sign, 3, a negative 14, and then a negative 10. And I'm going to put a little equal sign down here, and then a little box here, and then I'm going to proceed. So the first thing I'm going to do is I'm going to take this 3, and I'm going to bring it down. Then I'm going to do 2 times 3. Well, 2 times 3 is 6. And then I'm going to do the arithmetic here. Negative 14 and 6 is 8. Positive 8. I'm sorry, negative 8. Okay, and I'm going to do negative 8 times a positive 2, which is negative 16. And then negative 10 and a negative 16 gives me a negative 26. Okay, so what happens here is that my dividend is a second-degree polynomial. If it's a second-degree polynomial and I'm dividing by a first-degree polynomial, right, I'm going to go down one exponent. So 2 minus 1 is 1. So this is going to turn into a 3x minus 8 with a remainder of negative 26. Okay, so what happens here is if I did quotient plus remainder over divisor, this is my quotient, this is my remainder, and of course this up here, let's do this, let's just put an arrow, is my, crap, what did I put, DVR? I never forgot. This is my divisor, okay? Or alternatively, this is my divisor, just with the opposite sign of it. As long as you're okay knowing that, okay, so that the divisor is a 2, therefore my divisor is going to be my x minus 2. Okay, so my solution here will be quotient 3x minus 8 plus my remainder, which is a negative 26, over my divisor, which is an x minus 2. So 3x minus 8 plus a negative 26 divided by x minus 2. There it is. 3x minus 8 plus a negative 26 divided by x minus 2. So we could do long division, but if you have the option, I would do synthetic division. It's so much easier. and you get your solution. This is the exact same solution. So again, this is the exact same example we did earlier, just we did synthetic division. Okay, so that's essentially example 5, but let's go ahead to example 6, because example 6 is just a tad, I wouldn't say harder, but it's definitely going to be one of those issues that pop up on your homework, and you'll be like, oh no, but you're going to remember, oh, I already know how to do it because I was taught how to do it. So this reads, divide the polynomial by using synthetic division. So remember how earlier what we had to do is we had to fill in gaps, right? We had to fill in gaps, like if an x squared is being skipped, we had to put a 0x squared. Well, in this particular case, we have to do it again. Okay, so we're going to do it again. So my divisor is p minus 3, so I'm going to put a 3 in the box all by its lonesome. And then I'm going to go in descending order, right? So p to the fourth, that's an implied 1 in front of p to the fourth. There is no p cubed, there is no p squared, there is no p to the first. But there is a negative 81. Okay, so I'm not skipping any terms here, and well, that's how you set it up. So we're going to put a little box here and then another box here, which, by the way, this box in here is where the remainder goes. So I just go ahead and write that, right? This and that little circle is the remainder, so I'll go ahead and write that. Okay, so here we go. Similar to what we did a moment ago, we're just going to bring this 1 down. 1. 1 times 3, well, that's 3. 0 and 3 is 3. 3 times 3 is 9. 0 and 9 is 9. And 9 times 3 is 27. 27 and 0 is 27. And 27 times 3 is 81. And then negative 81 and 81, well, that's just 0. So same thing, like kind of what I did before. Remember I said, all right, so on the previous example, I said this is a second degree polynomial. My dividend is second degree polynomial. So my solution is going to be a third degree polynomial. You're going down 1. I'm sorry. In this particular case, my solution was a first degree polynomial. Got ahead of myself. In this particular case, we have a fourth degree polynomial. Therefore, my solution is going to be a third degree polynomial. So we're going to have x cubed, x cubed, x squared, x, and then my constant is 27. Okay, so my solution is going to be quotient, which is x cubed plus 3x squared plus 9x plus 27 plus my remainder, which is 0. So that's it. I don't have to mess with anything because 0 over anything is going to be 0. So my solution is just simply this. Okay? And that concludes the lecture on dividing polynomials.